Okay, we're doing Unit 6, Section 2, Day 2 notes today. These aren't as long as the Unit 6, Section 2, Day 1 notes. Let's jump in with the warm-up. We're just graphing the line, y equals negative 3/2 x plus 1. This is hopefully something you know how to do. Y-intercept is 1. Our slope is going to be negative 3 over 2. So put a point here, and we're going to go down 3 over 2, down 3 over 2. We can go the other direction as well. We have this line, just like that. All right, let's get to what we're talking about today. We're talking about absolute value functions today. If you don't know, an absolute, absolute, I guess it's written right here, value function is the distance from 0 on a number line. So for example, negative 5 and 5 are both 5 units from 0 on the number line. You've seen this before. Absolute values, you have these little bars, and the absolute value of negative 5 is just equal to 5. The absolute value of positive 5 is also equal to 5. Basically, it just takes any negative answer you get in here, and it makes it positive. Positive answers are going to stay positive as well. All right, so we're going to look at the graphs of these absolute value functions. We're going to start with the parent function. So this is just the basic absolute value graph if we have f of x equal to the absolute value of x. So if we plug in negative 3, well, the absolute value of negative 3 is 3. If we plug in negative 2, we get 2. Negative 1, we get 1. If we plug in 0, the absolute value of 0 is 0. And then for these positive numbers, we're just going to get out what we're plugging in. So the absolute value of 1 is 1, absolute value of 2 is 2, and 3 for 3. If we plot these points, so negative 3, 3, negative 2, 2, negative 1, 1, 0, and then 1, 1, 2, 2, 3, 3, what we get is this thing that kind of looks like a parabola. But instead of it sort of curving upwards, we have sort of two linear lines coming from this vertex point. So this point where they sort of converge, that's called your vertex. What is the slope of f of x when x is less than 0? So going this way, our slope would be sort of, it's going down 1 over 1, down 1 over 1, so negative 1 over 1. What is the slope, which is just negative 1? And what is the slope for x values greater than 0? I don't know why they put an equal sign there. We're going to get rid of the equal. It doesn't matter where the equal sign goes. X values greater than 0, it's going up 1 over 1, up 1 over 1, up 1 over 1. So 1 over 1, which is 1. Remember, when you're doing slope, you're reading it from left to right. So even though, the vertex is sort of the center, I didn't read this 1 over here as up 1 over 1. We're going left to right. So this is going down 1 over 1, down 1 over 1, whereas this one is going up 1 over 1, up 1 over 1. What is the vertex of f of x? I just sort of pointed to it. The vertex here is 0, 0. And then the last part here, does this previous graph remind you of a parabola? Well, yeah, it does, but no curves. These are linear lines sort of coming from the vertex. It's making a V instead of a U. All right, so let's flip over. The first thing on this next page is a summary, which has a lot of great stuff on it. We're just going to focus on a few things here. This is all excellent stuff, but here's what you need to focus on. The general form for an absolute value function is this guy right here. Put this in a box. And then this is important. The vertex is h comma k. And this right here is important. A is the slope of the right side of your graph. All this other stuff is nice. You can use it, but we're not really going to mess with it that much. One thing I need to keep in mind here, this a value and this part right here, I'm going to draw a little arrow out. I'm going to make a little note here. We must factor inside if possible. and this is going to be the only complicated part of the notes today, is if we have to factor inside. I'm going to try to make it as easy as possible, but that's something we need to keep in mind. All right, so let's get down. I want to look at example 3 first. We're going to skip example 2. We're going to go back to it, but I want to look at example 3. The first thing you're going to do when you're trying to graph these is identify what is the vertex. So I had you, box some things in up here. And this function right here is sort of the general form for it, where the vertex is h comma k. So h is sort of inside the absolute value bars with the x, and the k value is what's ever being added or subtracted outside. With the h, it's just like it was with parabolas and like almost everything else we did in here. You sort of do the opposite. So down here, where it says x plus 1 and then plus 4, so the 1 value is your h and the k value is your 4. But we want to do the opposite with the h. So it's going to be -1 for our h value and 4 for our k value. So our vertex is going to be -1, 4. And you always do the opposite with the h. Before we graph this, I want to write down one more thing. I want to write down what is the a value. The a value is found in front of the absolute value symbol, and the a is going to be the slope of the right side of our graph. So down here, our a value is -2. So when I go to graph this, here's what we're going to do. We're going to graph our vertex, -1, 4. That's sort of going to be the center of your graph. And then we're going to go ahead and graph the right side. The right side slope is going to be whatever the a value is. So the slope for the right side is going to be -2 over 1. We're going to go down 2 over 1, down 2 over 1, down 2 over 1. For the left side, you just want to flip the sign. So instead of it being -2 over 1, the slope on the left side will be +2 over 1. But this gets kind of tricky, because if we're going up 2 over 1, well, we're coming to this point. So we need to think about sort of going up 2 over 1, up 2 over 1 to get to this point. The easiest way to do this is just to think of this as sort of being mirrored over. So, sort of going down to left 1. And what this does, this creates a graph that goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And it meets at the vertex. So when you go to graph these, the easiest way to do this, graph the vertex, graph the right side, and then sort of graph the left side, just sort of doing it the opposite direction. Let's go up to example 2. So our vertex on example 2 is supposed to be h comma k. If we're looking inside the absolute value bar, there is no value with the x inside the absolute value bar, so our h value is going to be 0. Our k value is the number on the outside. We don't change the sign with that. It's going to be -1. Our a value is going to be the number that's out front of the absolute value sign. That's going to be 4 here. So if we graph 0, -1 to start with, that's our vertex. And the a value is the slope on the right side. The slope is going to be 4 over 1. So we're going to go up 4 over 1. And I guess that's all we can graph here. We're going to have it look like this. On the left side, we just want to sort of do the opposite. Instead of going up 4 sort of over 1, we're going to go up 4 left 1. And what this creates is down 4 over 1 when we come from this side. And that's our graph. All right, example 4. So if hopefully you were thinking this was kind of easy. Hopefully I didn't screw up the teaching on this. This last part is sort of the one tricky part to this. Underline this. Make sure the absolute value is factored before graphing. So I'm gonna write this out to the side here. So inside, we can factor this 2x minus 6. We can take out a 2. So we're going to have -2, and then I'm going to put the 2 parenthesis x minus 3, close absolute value bar, minus 3. Okay, that's not that difficult. The annoying thing is, if you take out a number inside this, when you go to graph it, you need to go ahead and take this number and multiply it out front. What I mean by that is we can go ahead and take this 2 and move it out front and say 2 times negative 2 is negative 4. And then inside the absolute value, we have x minus 3, and then we still have the minus 3 hanging out here. So that negative 4 is coming from saying negative 2 times 2 is negative 4. Notice it's still negative because the negative was on the outside already. So we don't want to take the absolute value of this negative because this negative was outside the absolute value bar. All right, our vertex. I'm looking at this guy right here. I'm looking at this final sort of factored function. Our vertex is going to be 3 comma negative 3. Remember, we're taking the opposite of the number inside the absolute value bar. Our a value is negative 4. That's the number on the outside of the absolute value. Don't say negative 2. We want to take the a value that we get after we factor. All right. So if we plot our vertex 3, negative 3, we get a point right here. And on the right side of our graph, our slope is negative 4 over 1, so we're going down 4 over 1, down 4 over 1. And on the left side, we're doing the same thing. We're just going the other direction, down 4 to our left 1. And what that does is that creates a slope that's up 4, right 1, up 4, right 1. All right. If you flip to the next page, there's sort of one more example and then sort of 2 of these silly examples right here. Example 5 throws sort of one more wrinkle into it. Again, we can factor the inside, and we need to do that. I'm going to put this out to the side here. And so I'm going to take out a negative 2 from the negative 2x minus 8. I'm going to get negative 2 in parentheses x plus 4. Because we took out a negative, it changed the sign of both of those. And then we have the plus 1 still at the end. This time, when we take the negative 2 out and multiply it to the 3, but because we got to take it out to the front, because the negative is inside the absolute value bar, we want to go ahead and take the absolute value of negative 2 and multiply that by 3. So absolute value of negative 2 is 2, and 2 times 3 is 6. So we're going to end up with 6, absolute value bar, x plus 4 plus 1. So the difference between example 4 and example 5. If you're multiplying sort of the two numbers together, if the negative's inside the absolute value bar, then make it positive. If the negative was outside the absolute value bar, keep it negative. All right, vertex here is going to be negative 4, 1. Our a value, we're looking at our factored 1, is going to be 6. And so if I plot this point, negative 4, 1, and then our slope is, for the right side of our graph, is up 6 over 1. Get something that looks like that. We're going to do the opposite on the other side, so up 6, left 1. Again, this creates a slope of down 6 over 1. All right. These last two are kind of goofy. We didn't talk about these at all, and there's not in the homework, but if you were going backwards, if I was asking you to write an absolute value function for these graphs, there's actually multiple answers you could give me. But if you're just giving me the basic one, I would do the following. Write down your vertex. So the vertex for this graph right here is negative 2, 0. Write down your a value. Our a value is the slope on the right side. We're going up 2 over 1, which is just 2. And then go to create your function. You would say f of x equals, put your a value up front, absolute value, x, take the opposite of the x value in your vertex, so x plus 2, and then take this last value and you add that to the end. It's kind of stupid to put plus 0 or minus 0. You really don't need that last part there at all, but I'm just trying to make a point of where that would go. All right. Number 2, I don't know why they made these dotted. My guess is whoever made this sheet stole it from the internet. It is possible to have inequalities with absolute value bars, but we're not doing that. So we don't have any dotted lines that we're going to have to worry about. And again, if you're writing the equation, I do the same thing. Figure out what the vertex is. The vertex is 3, 2. And figure out what the a value is. The a value is the slope on the right side. You're going down 1 over 1, down 1 over 1. So negative 1 over 1, which is negative 1. When you go to write your function, you would say f of x, hopefully y'all can see this, equals negative 1, absolute value bar, x minus 3. We want to do the opposite. And then plus 2. I hope y'all can see that. Okay. All right. That's it for the notes. Make sure you go on, do your digital learning quiz thingy before you finish today. Have a good day.